Our last type of solving for systems of equations is called elimination method. Although if you're looking on the internet, it might also be called the combination method. Now, this is useful when we see equations in standard form, which looks like this, where you'd have something like 3x minus 2y equals 6. So we've got numbers where the a, b, and c go, and it's not very handy for graphing. There is a method for it, but mostly it's handy for situations. In real life, a lot of things get added or subtracted together to equal a whole number. So here's our example. When would I use standard form? If 50 people attended back to school night, and X represented students and Y represented parents, but all I knew was that 50 people total attended, I could write an equation X plus Y, so students plus parents equals 50 people. And it makes way more sense to do this than the equivalent Y equals negative X plus 50, or you might write it as 50 minus X. That might make sense, but really it makes the most sense to just say that we added the people together and they equaled the total. So you can see that standard form comes in handy in some real life situations. For elimination method, here are some steps. You're going to have two of these equations in standard form, and your job is to look for a variable that has opposite signs and the same coefficient. So here, looking at the x's, they don't have the same coefficient, and they're both positive, so they don't have opposite signs. But if I look at the y's, that's very convenient. They have the same coefficient of 1, but opposite signs. One's negative, one is positive. Now, if I add these two things together, they equal 0, which is how they become eliminated. Our next step is to add the equations together. And when I do that step, the y's should be gone. They should be eliminated. So I'm able to get x all by itself. Now our last step is the same as it has been for the other forms of solving systems, and that's just to plug it back in to find the other variable. Not too hard, but it does depend on finding that variable with opposite signs and the same coefficient. So now you should be asking me the question, well, what if nothing will cancel? Well, we can do a little bit of fudging at the beginning in order to make it so that it will cancel. And the way we do that is we identify a good opportunity. So we have two possible options here. These are the equations I started with. You'll notice that the y's have the same coefficient, but not opposite signs. The x's have opposite signs, but not the same coefficient. One is a 3 and one is a 1. So I could choose either of these, but I've chosen to deal with the y's. I only have to change their sign in order for them to eliminate. So what I'm going to do is I'm going to multiply one of the two equations, and it doesn't matter which one you pick, because either way something will cancel. I chose the second one, and I draw parentheses around the whole equation because I have to change every term in the equation. I'm going to multiply them all by -1 in order to change the sign. You don't have to use -1 if you need to use, for instance, I could have done the x's by choosing +3 here. Whatever number will allow something to cancel is the number you're going to multiply every term by. When I do that, x turns into -x, positive 2y turns into -2y, positive 5 turns into -5. So this is my new equation that will eliminate. These are the equations that I'm going to add. You'll notice that the first one was just copied, and then the second one is with the multiplication that I just did. We're going to add them together, and remember, when we add two negatives, they just become more negative. So I end up with -4x is equal to -8. Divide and solve, I get x is equal to 2. Now, when I went to plug this back in, I chose one of the original equations because I liked that x was positive and that I didn't have to multiply it. You could use the new modified equation, or you could choose the other equation. It doesn't really matter which one you go with. You should get the same exact value. When I plug this in and solve, y was equal to 3/2. I could change that to a decimal if I wanted to by dividing. 3 divided by 2 is 1.5. So again, if nothing will cancel, you have a method. You multiply one of the equations by a number that will allow something to cancel. Good luck on this in class.